Alright, for this video, we're still solving our equations here. So we have 22 through 24 of your Unit 7 test review. Number 22, we have an exponent equals an exponent. So what we did on the previous question for number 21 was we got our bases to be the same. What we know is 8 and 16 are not prime numbers, so let's go ahead and get them down to prime numbers. I know 8 is 4 and 2, this is 2 and 2. So we have 2 raised to the third power instead of 8. And then we have that 5x on the outside. Okay. 16, I know, is 4 and 4. And each of those are 2 and 2. So 2 to the fourth. And I have 3x plus 4 from the original problem. So since our bases for our exponents are 2, we can kind of just like go ahead and cross them out. What we have left over is 3 times 5x, which is 15x on the left. And then we have 4 times 3x plus 4. So the thing that you guys have to remember is make sure you distribute this 4 out. It's not just to the first term, but it's to both. So I have 12x plus 16. So I'm going to get all the x's on one side. Divide by 3. X is equal to 16 thirds. Just double check, just because sometimes it might be an extraneous solution or we did step incorrectly. So I'm going to go ahead and store 16 thirds as x. Okay, 5.3 repeating. We're going to go ahead and put 8 raised to the 5x power. It's that huge number. And then we'll do 16 raised to the 3x plus 4 power. And that's the same huge number. Okay, so the left side is equal to the right side. We know our answer is correct. So our answer here is x equals 16 thirds. For 23, we have a few things. We always say do your algebra 1 before your algebra 2. So I know I need to get rid of this 3. Since we're adding 3, we have to undo that by subtracting. Alright, we're at a point where we have to get rid of this 10. And 10 is the base of my exponent. Okay, so in this case we have, okay, so an exponent is equal to a number. So we have to log each side. So what is the base of my log? It's going to match the base of my exponent. So I'm going to use log, okay, base 10 of 10 to the 2x power is equal to, whatever you do to the left, you have to do to the right, log base 10 of 5. So this log base 10 crosses out that 10, and we're just left with 2x. Remember, log base 10 is you usually don't see this subscript 10, the base. Okay, it's the common log, so you could just go ahead and use log of 5. We'll divide by 2. Log of 5 divided by 2. And it's approximately, and we're going to go ahead and type this into our calculator. We're going to go ahead and round it to, let's say, 3 decimal places. 0. Well, this 4 doesn't round that 9 up. 0.349. Okay. So that wasn't too bad. 24 is more of a challenge. There's a lot more going on. Okay. What I notice is there's some algebra 1 that we have to do. We have to go ahead and add 3 to get 10 times the natural log of 100x is equal to 120. This 10 in front I can get rid of because all we're doing is we're multiplying, so we have to undo that by dividing. Now we're down to the algebra 2 part. So the natural log of 100x is equal to 12. We have a log equal to a number. So let's take a look at what we want to do. Log is equal to a number, so we have to exponentiate each side. Okay, so that means this is actually going to be an exponent. And just as a reminder, if you have a natural log, your base is this imaginary e. Okay, so what we have to do is exponentiate each side. So I'm going to go ahead and say e is my base. natural log of 100x equals, we used e as the base, with the e as the base on this side as well. Okay, these are right next to each other, so you can cross them out. All I have is 100x on the left. Still have e to the 12th on the right. Divide by 100. X equal e to the 12th divided by 100, which is approximately, let's see what that is equal to. The 12th divided by 100. 1,627.548. Tight squeeze there. Okay, so that's how you can solve those 4 different types of equations that you'll see on your test.